Okay, great. We used the serial monitor to test our sensor, printed the result to our computer screen, and now we know that our speed sensor provide value between 0 to 1033. Now this process is useful for many other sensors. However, while using the built-in delay function, speed will be measured in milliseconds, and the relation is of course opposite. More delay is less speed. Let's say that we would like that the speed range will be between 100 to 700 milliseconds and not between 0 to 1033. In that case, some range normalization or mapping will be needed. The good news is that there is some simple to use function that will help us to perform such mapping. Using the analog read function, we will read the value from the analog input pin correlated to the voltage our sensor is putting out, which in our case should indicate the needed LED speed. And we saw that the value range is between 0 to 1033. Now, for mapping or normalize this range to other range, we have a dedicated built-in function. This function remap a number from one range to other. So actually it is one of the most useful functions for mapping sensor values. It is called map and use 4 input parameters. The first parameter is the actual value that we would like to map. The second and third parameters are the original low and high values. And this is where the analog serial monitor will help us to check the value coming from our sensor. Finally, the fourth and fifth parameters are the new low and high value range that we want to map the original value. In our case, we just want to make sure the maximum speed will be 100 milliseconds and the minimum speed will be 700 milliseconds. You will see that this is going to be useful also for the second sensor we use to set up the LED brightness, because on one side the analog read return a value in a range of 0 to 1033, but analog write function that we are planning to use can only make a value from 0 to 255. In addition, another thing that comes up frequently is the need to reverse a range of value. Again, in our case, speed and delay are opposite. Less delay is more speed. So it makes sense to reverse the range of value, so that instead of outputting a 100 to 700, we would flip it to 700 to 100. And the way to perform it is just by flipping the last two values. Easy and very useful. Something that is less relevant for our specific case right now, but can be relevant to other sensor types that you may use in the future. We saw that the map function is useful for changing the start and end value of a variable. However, it is not limit them to only those values. Leaving value outside of the map function might be useful if we only want to map a smaller part of a range of value. Taking for example the need to ignore reading from a proximity sensor that detects something that is maybe too far away, or ignore a sound below some threshold level, and so on. So if we want to force or filter the value to very specific limited range, we would use the constraint function. The syntax for this function will be a constraint and 3 parameters. The first parameter is the value that we want to constrain to a specific range. The next 2 parameters represent the needed minimum and maximum value in that new range. Now, let's say that after analyzing our data, looking on the range that are being returned by our sensor, we find that the minimum reported value average is around 40 and the maximum is around 1000. We could constrain this value before remapping them to a new range. So taking for example the following code. This code will limit the reading to anything between 40 and 1000, ignoring any reading that exceed this minimum or maximum, and then followed by remapping that using the analog value to a more usable range of 100 to 700. Okay, that's all. That's the way to use the constraint. However, in our case, it is not needed, but maybe you will use that in other sensor that you are going to use in some future project.